Okay, here is one of the airplane problems with vectors, and you can read along with me. An airplane has an airspeed of 500 miles per hour at a bearing of 140 degrees. So, again, we're going somewhere warm, right? Here to Florida, so think nice beaches. The wind velocity is from the southwest at 40 miles per hour. Find the resultant ground speed and direction of the plane. So first thing they want us to do is sketch each vector, the wind and airspeed. I'm going to draw a picture of the whole thing first, actually, to help myself out, too. So I'm going to go ahead and draw in north, south, east, and west. There's north, so the airplane, let's go with pink here for the airplane. It has an airspeed of 500 miles per hour at a bearing of 140. So remember, bearings from north, opening clockwise this time. So if we do that, 140 degrees, well, right here to east, that's 90, so another 50 past that. So we're going to be somewhere in here for our airplane. Remember that the vector itself represents the 500 miles per hour. Then from there, we've got some wind that's pushing its plane. This part's kind of interesting. It says the wind is from the southwest at 40 miles per hour. So I'm going to draw in another compass for myself here, north, south, east, and west, so I can draw that bearing well. But it's like, well, does it say bearing? It says from the southwest. Big keyword here, from the southwest. So not to the southwest, from. So if you think about this being the picture, the wind's going this way, from the southwest. Okay, I'll even draw an arrow in here. Imagine the wind blowing from the southwest. Okay, those aren't my vectors, I'm just showing you this is the wind. So if that's the wind, then when I'm going to attach it to this vector to show the new direction, when I'm adding my two vectors together, it's going to be actually going towards the northeast, really. So from the southwest means towards the northeast. Okay, and I made that a little bit long, but that's okay. Just want to be able to draw in here 45 degrees. Remember, the 40 miles per hour then is the magnitude of that one. So like I said, it's a little bit further than it should be, but it gives us at least a general idea. And then our resultant right here is going to be those two things added together, which is the ground speed vector that I want in the end. Okay, so this green vector is really what we're trying to find information about. And like I said, it's a little bit further up than it should be, but it's going to be close enough to get the general idea. Okay, so again, we should probably separate them out here, make the wind and the airspeed separate for parts B, C, and so on that I'm going to ask you about. So I'm going to go ahead and separate them right here so that we can look at them more. So if I kind of blow up the blue part there, the wind only, looks like this. We've got 45 degrees in both places, and we've got 40 miles per hour for the length there, okay, or the magnitude. And then airspeed of the plane. Again, that was that original pink one, so I'm just going to do just that one on here as well. We've got a bearing, remember, of 140 and a magnitude of 500 miles per hour. Okay, so we have them separated now so that we'll be able to answer the questions, because the next question is find the vector representing the wind. Okay, so I'm going to be using this blue picture right here to help me out. I'm going to go ahead and drop down a perpendicular here because I want to find the horizontal and vertical components of that wind vector. And it's really helpful right now to tell yourself these are both going to be positive numbers. So go ahead and even write it down here. and know this is going to be positive, this is going to be positive. And of course we don't have to like have the positive, but it just really makes me think about it. To find x and y, I'm going to have to use sine, cosine, or tangent. Remember that 45 degrees is a special right triangle, so when I'm doing this part, when I'm trying to find x, I'll go ahead and show the work down here. I'm going to do cosine of 45 equals adjacent over hypotenuse, so x over 40. And when I cross multiply, I really need to think about that cosine of 45. I know that it's 1 over square root 2 or square root 2 over 2. So in the end here, when I simplify, I can keep this exact. And a lot of times on WebAssign, it's going to want you to keep it exact. Now, the good news about this is that that's my horizontal component, or x component. This is a isosceles triangle, right? So y's got to be exactly the same thing. I mean, I can go ahead and do sine 45 equals y over 40, but I'm going to get the same thing this time. So that saves us a little bit of time on this specific problem. So, again, that's part A. Well, part B, actually, I labeled it, but that's the first kind of question we're usually asked. The next kind of question we're usually asked for part C is find the vector representing the plane's airspeed. So again, we have this picture up here, and we're going to do the same kind of stuff with it then. Okay, we're going to go ahead and drop down a perpendicular. We want to find this and this. I probably need to figure out what this angle then the one is, because the 140 is not going to be very helpful. So think, if that's 140, from north to east is 90. So if I do 140 minus 90, this has got to be 50 right here. So again, as I'm doing the work for this problem, I'm trying to find x and y. I'm using sine, cosine, or tangent, whatever makes sense here. So if I want to find x, and actually before that, again, I might as well start writing the answer over here and realize that x is going to be a positive, and here's the really important part, y this time is negative. If I don't consider that, then my whole problem's getting messed up. So this is a really big deal, and it's the thing that's most commonly missed. So again, let's go ahead and set up our trig functions here. So we've got cosine of 50 equals x over 500. If I go ahead and multiply 500 cosine of 50, I'm going to get about, and cosine of 50 is not something that I have an exact value, so I'm just going to type into a calculator. And when I type that in a calculator, I'm going to get 321.39. When I do sine of 50, to find y, I'm going to do 500 cosine 50 degrees in my calculator again. And my calculator is going to give me about 383.02. Again, since I already wrote it over here, it's really nice that I have the negative sign. Okay, and again, you don't have to have these positive signs. We can get rid of those. What I was trying to get you to think about is that you got to have the negative one. That's the one that matters, right? This one that I have circled right here. Let's make that 20 again. Okay, so all that being said, what's the point? Well, the original directions were find the resultant ground speed and direction of the plane. Well, I need a resultant vector then. So most of the time, the next question is find the resultant vector representing the ground speed of the plane. And here's where our original picture is really awesome. So here's my original airspeed, here's the wind, the green is what we're talking about for the resultant. That's adding two vectors. Okay, when I put them tip to tail like this, this is the resultant. So that means I'm just adding part B plus part C. So I'm really just doing 20 square root 2, 20 square root 2 plus 321.39, negative 383.02. And I'm just typing that all in the calculator. Okay, when I type that all in a calculator, I'm going to get for the resultant 349.67 negative 354.74. And I keep rounding to 2 decimal places because I think that's what WebAssign has you do. Okay, they will make you keep things exact. So if you have a decimal up here when you could have an exact value, you'll need to change it back. So if you're getting something that's telling you it's wrong, it's because it didn't ask you to round. Okay, so see if this makes sense, that it could be 349 in the horizontal direction and negative 354 in the vertical direction. I hope that makes sense with this resultant for you. I know that mine's a little bit off because I made my blue vector a little bit too long, so, but in general it's like this answer makes sense. Okay, so then the last part, like actually answering the question, is going to be finding that ground speed, which is really asking you for what? Well, it's asking you for this, like what's that actual distance or length, and in this case it's representing that miles per hour force. Okay, so it is asking you for the magnitude. Okay, it might not say that, but it's asking you for the magnitude. So again, remember how we find magnitude or something. So if I go back up and let's call this vector r just for resultant, then remember I'm finding magnitude, there's a symbol for magnitude, and I'm just doing square root of the two components squared and added together. Okay, basically distance formula or Pythagorean theorem. Out of that, I'm going to end up getting 498.11 miles per hour. Okay, and then the last question, finding the direction. Takes a little bit more thought here. Because I have to go back to the original picture, and I'm just going to sketch it since we're kind of running out of space here again. What in the original picture mean that resultant part. So I'm going to draw it in green again like it was up here at the top. So that resultant was kind of in this general direction. Well, we just found up here the components of that. So we found that it's 349.67 this way, and this is when I'm dropped down perpendicular is what I mean. And we found it's negative 354.74 this way. And actually we even found it's 498.11 this way, so we could use that too, but we usually just stick with these guys. Let's find this angle, and I'm going to call it theta prime, like a little apostrophe, first. Okay, we can do that easily using tangent. So we've got tangent of our, I'm calling it the reference angle, is negative 354.74 divided by 349.67. I need to do inverse tangent to both sides. So that reference angle in there is about negative 45.41 degrees. So that's how you can tell my picture was a little bit off, but pretty close. So if we're saying this right here is negative 45.41 degrees, that's close to the answer. But since everything in the picture was given to us as a bearing, we should probably say this is a bearing. So if we want to say that bearing from north, let's say, so north is here, and I want to say what the bearing is from there, I'm going to have to do 90 degrees, because northeast is 90, plus that 45.41 degrees. So I could say it has a bearing of 135.41 degrees. The other way, if you want to say, some of you might be like, well, it's in like a southeast direction. And I agree with you, southeast, but then I've got to say, okay, to the east, so I've got to figure out how much this angle is right here. And again, that's not so bad. I could just do 90 minus 45.41 and get that it's south 44.59 degrees east. So either one of those is acceptable for a final answer. Okay, hope that helped. Thanks for listening.